In this project, we were tasked with designing a sterilizer for low-middle income countries for instruments used in childbirth. In developing countries where women have limited access to healthcare facilities, the instruments used in labor and delivery are few and far between. Thus, having a reliable and efficient sterilizer for those tools is imperative to limit the spread of postpartum infection and to aid as many women in childbirth as possible. In 2020, almost 95% of maternal complications occurred in low and lower middle income countries. This is greatly due to the lack of quality healthcare services available. One of the leading causes of maternal death is infection after childbirth. This can be greatly reduced with the use of proper sterilization for obstetric instruments. A 2019 study showed that the implementation of high-quality obstetric facilities in developing countries does not greatly improve maternal health care, as you would think. This is because of the lack of training amongst the staff. So it is very important that when designing our sterilizer, we considered those that are operating it and the environment it would be used in.
When brainstorming ideas, we were originally inspired by several modern healthcare technologies. Autoclaves were originally considered as they are the gold standard at the moment for sterilization. However, the resources were determined to be far too taxing for a low-income area. Thus, we pivoted to dry heat sterilizers. These devices operate at high temperatures for 1 to 2 hours to denature protons and disrupt the molecular structure of bacteria, viruses, and fungi. By circulating hot air evenly throughout a chamber, they ensure that all of the surfaces of the material are sterilized by being exposed to these lethal temperatures. This method is particularly suitable for heat-resistant and moisture-sensitive materials such as glassware, metal instruments, and powders. However, the high cost and energy demands of dry heat sterilizers do continue to pose challenges for low-income areas. To address these issues, we decided to improve the design by making it more portable and powered by solar panels. This increases accessibility and sustainability.
Design for the dry heat sterilizer. This is powered by solar power, which we can see by the solar panel on the top of the design here, as well as we have our general controls on the side here. The controls consist of a button and a knob. The knob controls what temperature the sterilizer goes up to, and the button is an emergency switch off button. So in case of emergency or we need to stop it immediately, that red button right there is how we control that. For easy mobility, on the back here we have our handle so that the person can easily carry and set down the sterilizer as needed. So, to expand the uses to sterilize as much equipment as possible, on the inside here we have a rack design with the adjustable rack at 3 different levels so that as much equipment can be put in as necessary, as well as the size of the equipment can be adjusted, or it can be adjusted to suit the size of the equipment being put into the sterilizer.
Since our model is for instruments used during childbirth and they are all handheld, the size of the dry heat sterilizer would be around 31 liters or 280 by 460 millimeters, which is the size of an autoclave commonly found on laboratory benches. Based on the size of our portable model, the amount of money we spend on each sterilizer for its solar compartments round out to about $13.50. On average, the 31-liter autoclave costs around $1,300, while the average 31-liter dry heat sterilizer costs around $1,100. On top of the fact that the dry heat sterilizer is more cost efficient, it is more energy accessible and easier to use, while remaining on par in every other category compared to the autoclave when it comes to small instrument sterilization.